afternoon or morning or 2 a.m. Whenever you're watching this, I hope you're doing well. This video is on properties of matter, further classifying matter and its changes. I do want to take this moment to showcase my favorite element on the periodic table. This is bismuth. Bismuth has these perfect right angles. It forms these square crystals, and in the presence of oxygen, it makes this rainbow color effect. It's just super cool. But that just lends perfectly into our lesson today. All of those things that I just listed about bismuth are properties of matter. So color, shape, mass, and volume, all of these things are ways of looking at matter and classifying it. That takes us into our lesson objectives. What you should be able to get out of this lesson today is defining various properties of matter, classify properties of matter as physical or chemical, describe the flow of energy within a system during a phase change, and compare the kinetic energy of particles in 3 states of matter. And if you are taking notes on paper, typically that's a skill that I would teach you in the classroom because I think that's something that's learned. But since I'm not with you, I'm going to try to organize these lessons in such a way that would match the way you would take your notes. If you like to do headers, then your objectives in the beginning should match your headers throughout the PowerPoint. The first one being define various properties of matter. A physical property can be observed without altering chemical composition, and a chemical property cannot be observed without altering chemical composition. And here are a few examples. Color is one of the easiest physical properties to list. I can say, hey, this coffee cup is white, or bismuth is rainbow colored. I don't have to do anything to change the chemical composition of the sample in order to tell you the color. And that's what makes it a physical property. Same deal with density, which is mass over volume. Malleability, which is another word for flexibility. How easy is it to shape your sample into sheets? Think of aluminum foil. Aluminum is easy to make into those flat sheets, which is why it is that way. We have melting point, which is the temperature at which melting occurs, and boiling point, which is the temperature at which boiling occurs. Finally, we have conductivity. That is the ability to maintain an electrical current. An example of that is copper wire. Copper is a good conductor, and copper is used as wires, like I said, copper wire, for electrical components. On the flip side, we have chemical properties. Reactivity is the first one that comes to mind. That's the ability for something to react with another substance. So, for example, iron in the presence of oxygen forms rust. That's a chemical property. Flammability is the ability to catch fire. Paper is flammable, and in order for me to find that out, I have to set it on fire, which would then change the chemical compounds of the paper. And then heat of combustion, that's just the amount of heat released upon burning something. To find the heat of combustion, we have to combust the sample in question, and then we can experimentally find the heat that's released. Changes in matter. So chemistry is the study of matter and change. We look at these physical and chemical properties because it will allow us to say, hey, we have an unknown sample. Let's figure out what this is based on our observations and data we can collect from it. Just like properties of matter, changes in matter can be physical or chemical. That should say be. They can be physical or chemical. A physical change is a change that happens, but it does not cause a change in chemical composition. And chemical changes do cause changes in chemical composition, so just like our properties. How do we know if composition has changed? Chemical changes often cannot be reversed. For example, burning. Once you've burned a log of wood, you're left with ash and new compounds. You can't make those go back into the original log. Because it's not reversible, that's a good indicator that this is a chemical change. If a new substance is formed, like a gas, then we know we had a reaction. That's a chemical change. And finally, if there's a change in color, I would just be careful with that one because sometimes if there's a mixture of two substances, that can cause a change in color. And that's not necessarily a chemical reaction that occurred. There was no change, it's just dissolving. So I want you to go ahead and pause this and try to classify these as a physical change, chemical change, physical property, or chemical property. The first one is rotting fruit. I have a nice visual here for you. Clearly, this is not reversible, so we know it's chemical, and this apple here changed. It's a chemical change. Condensation is the process of going from gas to a liquid. So if you have a cold drink on a hot day, you might notice the little droplets forming on the glass. That's condensation. We're just going from a gas form of water to liquid form of water. The chemical composition did not change, just the state, so this is a physical change. Freezing point is a little different. Freezing point is just the temperature at which freezing would occur. The freezing isn't happening, it's just saying like water, for example, freezes at 0 degrees Celsius. That is a physical property. It tells me something about water, but something's not happening, so it's not a change. It's a really small differentiation there, but it is different. Then we have decomposing. If something has decomposed, you cannot undecompose it. You can't take a dead, decomposed fish, for example, and bring it back to life and have it. No, just none of that. That is a chemical change. If you crush an aluminum can, I ask myself, okay, the aluminum is squished. Is it still aluminum or did it change elements? Did it change compounds? No, it's still aluminum. It's just squished. That's a physical change. Last but not least, we have the ability to rust in the presence of oxygen. This tells me something about a substance, but it's not rusting, so that's a property. In order to know that something can rust, we would have to change the chemical composition, so it's a chemical property. Moving forward, I'm going to say a little bit more on phase changes just because this is a good time to do it. Matter typically exists in one of three phases: solid, liquid, or gas. In a solid, particles have the least amount of kinetic energy. Kinetic energy is energy in motion, so anytime something is moving, it has kinetic energy. Since solids have a definite shape and volume, particles are close together and they vibrate. As energy is added to the system, particles vibrate faster and faster and they begin to separate. In a liquid, particles are in contact with each other, but they slip past each other because they have more kinetic energy. Interactions between particles allow liquids to have a definite volume but no definite shape. These interactions can be broken as more energy is added to the system. I do want to pause here for a moment and say a little bit more about this definite shape and volume. What I mean by that is if you had a block of ice, for example, you can tell me what shape it is if you're looking at it. It's a cube, let's say. And we can measure the volume. It's not going to change no matter where we put it. If we melt that block of water by adding energy to it, it would then be in a liquid state and it has no definite shape anymore. Liquids are going to take the shape of the container that they happen to be in. So if it's in a cup, it'll be the shape of the cup. If we pour it out on the table, it's now the shape of the flat table. However, it's still a definite volume. If we have 100 liters of water in a cup, a really big cup, or if we have 100 liters of water on the floor, it's still the same volume, it's just spread out differently. Gases are a bit different. Gas particles have the most kinetic energy. There is no definite shape or volume because particles can move freely from each other. So you can't tell me the shape of air. It's just around. It's moving freely. We also can't tell you the volume of air because it's just moving freely. So here's a nice little visual for you. I'm sure you've seen this before, something like it, but just showing you how are the particles aligned in a solid. You can see in a liquid they're a bit further apart, and in a gas they're moving all around. They're not interacting with each other. They're each individually moving freely. And then we can see the phase changes going from solid to liquid, that's melting, and from liquid to solid, that's solidifying or freezing. From liquid to gas, that's boiling, vaporizing, evaporating, and from gas to liquid, that's condensing or liquefying. If we go from solid to gas, that is called subliming or sublimation. An example of that is dry ice tends to do this. At room temperature, carbon dioxide as a solid will just skip the liquid phase altogether and go straight to a gas. The last thing I want to note here is just let you know where we're headed. We've now looked at physical and chemical properties. We're going to go to next week and start looking at how does each element have physical and chemical properties? How does this table organize it? The periodic table is like our holy grail. Well, what we will find is that group 1 elements in this first vertical column are all going to react in similar ways. Same with group 2, and so on. Group 8, 7, 6, 5, 4, 3. Each column has a certain set of physical and chemical properties that they adhere to. And that is all for you today. As always, let me know if you have any questions, and you know where to find me.